Hello students. So today we will study drift of electrons and the origin of resistivity. So we have studied in the previous class that an electron will suffer collision with the heavy fixed ion, but after collision it will emerge with the same speed but in random direction. Now the positive charge, this is the heavy electrons because its mass is many more times than that of electrons. So if its inertial speed is v, then final speed is also v after collision, speed of the electron. Thus we see that speed of electron remains same after collision. The direction of motion of electrons are at random. The average velocity is 0. Let the number of electrons is equal to capital N, where small I represents 1, 2, 3 and up to n. Now let us take an ith electron, whose velocity is small v suffix I. Then the summation of all this, it is represented by 1 by n summation of vi is equal to 0, and it ranges from I is equal to 1 to n. The force required to move an electron minus E in the electric field E is equal to minus E into E. So F is equal to force is equal to mass into acceleration. So if we accelerate the electron, A is equal to, from this observation, A is equal to minus small e into the field divided by m. Now consider an ith electron at a given time t. This electron suffered its last collision just before t. Note the picture very carefully. This is not given in any book. So this is the collision point, and this is the ith electron. Just before collision, the position just before collision, let us see, it is ti. There is a time elapsed after collision. From the collision to this point, there is a time elapsed after collision is ti, and vi is the velocity of the last collision. Last collision means this point. This is the point of last collision, and the velocity at this point is small vi. Okay. Then capital Vi at time t is, we know from laws of motion, v is equal to u minus at, where v is the final velocity, e is the inertial velocity, a is the acceleration, and t is the time. So put it in this formula. The capital Vi, this is the final velocity, capital Vi, the final velocity, is equal to inertial velocity, small vi. We have seen here during collision, velocity of the last collision, this initial collision. We are trying to find the vi now. Here minus a into t. Here this t is the ti, and a means, we have studied in the previous page, acceleration is equal to minus e into e by m. Yes or no? Yes. So I'm going to the previous page. So this is a. So we are putting this value, and in place of a, and the value of capital Vi stands as like this. Now collision of electrons do not occur at regular intervals, but at random times. You must remember this, because an MCQ may come. Now let tau, this is represented by tau, is the average time between successive collision. Means when one collision is taking place, another collision is taking place. So the successive time, there is the average time between any successive collision. You can represent it by tau. then at a given time, some of the electrons would have spent some time more than tau. Yes or no? Suppose some electron is spending some time 5 microseconds. Some electron is spending some time 3 microseconds. The average, suppose the average is 4 microseconds. So some electron is spending less than the average, some electron is spending more than. So time is less than tau for some and time is greater than tau for some. So average value of Ti is equal to tau, and this tau is known as the relaxation time. We have taken I is equal to 1, 2, number 1, 2, dot, 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 up to n. So the previous equation shows that Vi is equal to Vi minus E into electric field D by M into Ti. Averaging over n electrons at any given time T gives average velocity is the Vd. Yes or no? So average velocity Vd is equal to this Vi average, this one, minus the small v1 average, small vi, this is the initial velocity, this average, this is the final velocity average, minus E by m. This is T1 Ti average. Now since Vi average is 0, we put this 0 and this now comes minus E by m. Therefore Vd is equal to minus E into E by m into tau. Thus average velocity of electrons is c. Though it is related to acceleration, although the electrons is accelerated, we have seen previously, we have found value of a, that means there is a bit of acceleration, but still the equation is independent of time. This is the phenomena of drift, and this velocity is called drift velocity. Got my point? So this is the conductor. The electric field E is passing through the conductor, direction of electric field in this way. This is direction of the electric field, and let us take an area which is 90 degree to electric field. Now because of drift, there will be net transport of charges across an area perpendicular. Let that planar area is equal to A. This is charging, this is A. Now in a time delta t, the electron that crosses to the left of the area, the electron that crosses the left of the area is equal to did velocity into time. We know S is equal to Vd, distance traveled is equal to velocity into time. Here velocity is the Vd, mod of Vd, into time is the delta t. Let number of electrons per unit volume is small n. Okay? Then there small n into Vd, this is the distance. This is the distance, S is equal to Vt. Throughout the distance, n number of electron crosses through that area A. So number of electrons per unit volume we have already taken as A. So total charge transported across E is equal to minus n Vd del T dot A. Since the electron is negative, it is taken as minus. The amount of charge crossing the area in time delta t is by definition, we know, equal to I into t. Here t means del t. Yes or no? So I into del t gives you the value of q. Now from here we have got the total charge q is equal to minus n Vd del t dot e dot a. Yes or no? So we have deducted, so del t cancels out. Now we have deducted in the last page, that is did velocity mod of Vd is equal to minus E by m into tau. E is the electron, E is the electric field, this is the mass, and this is the tau. Tau is the relaxation time. Now putting the value of Vd in equation 1, if we replace this Vd, it comes I into del t, this is n into Ea, put in place of Vd, put this E by m. Now the tau into del t, in place of Vd we are putting this value. This value is coming over here. So this gives I into del t, E is the E square into A by m into A by m. This is the tau, this is n, this is the del t. Now so del t cancels out. Now put I is equal to mod of j dot a. We already know j is equal to current density is equal to current divided by area. Therefore current is equal to current density into area. Replace the value of I in this equation. This I is replaced by this value, which gives n is squared A by m into tau into A cancels out. Now vector j is parallel to vector g, hence j is equal to n square by m into tau dot e. So n square by m into tau is called the conductivity. Now here it is assumed that tau and n are constant and it is independent of E. Thus electrical conduction reproduces Ohm's law. So this one you must remember that this sigma is denoted by conductivity. It represents n square m dot tau. This is a very simple equation. Go step by step, practice in your own way, you will get the result. So thank you. Next we will study that mobility and we'll study limitations of Ohm's law. Up to this we have studied the Ohm's law. So bye, have a great time.